Good morning, everyone, and I welcome you to the session on Design Your Own UAV by AthrV-Ed. My name is Jocelyn Corda. I'm a fourth year mechanical engineering student at NMM ITNIT. So I'm here presenting you our session on Design Your Own UAV on behalf of AthrV-Ed. So before we start into the session, I want you to get a brief idea on to what your UAV is, and this session will be covering the brief aspects and just the intro part of the introduction to UAV. So coming to what we learned in this session, we'll be having introduction, classification as in classification specific to UAVs, fundamentals that are we will mainly concentrate on two types of UAVs: the applications of UAVs, the basic components as in the bare bone minimum components required to fly a UAV, wiring and setup of a multi-rotor, just a basic wiring and setup guide for you to understand how multi-rotor works, and finally safety and DGCA guidelines that have been set up by the government of India. So coming to UAV, UAV stands for Unmanned Aerial Vehicle. It is also known as Unmanned Aerial System, Remotely Piloted Aircraft System, and commonly known as drone. So what makes UAV stand out is that it is mainly used for its autonomous characteristics. That is, autonomous flight path. You give a certain instructions and it will carry out those instructions on its own. UAV mainly consists of uh, three parts. That is aircraft, the UAV itself, the ground station, a device that is used to relay information to the UAV, and a pilot who controls the UAV. So, what are the main classification of UAVs? We mainly classify into four types: fixed wing, multi-rotor, VTOL, and ornithopter. Firstly, is for fixed wing. It is very much similar to commercial airplanes that we fly in. In this, the principle is that air flowing over the wing produces lift, and this lift is used to carry up the aircraft. This is mainly used for long range missions and for efficient flights. By the virtue of the wing, you can get a lot of flight time and you can reach far off distances. In such scenarios, in such cases, we use fixed wings. The main drawback of fixed wing is that it needs large takeoff area, like what we see in an airport. In It's comparatively small, but we need a certain amount of takeoff area and also landing area. So this is very much difficult to be implemented in space constrained regions. The next one is being multi-rotor. That is, we see mainly nowadays that is being mostly and widely used. So what is a rotor? Rotor is basically a motor that is attached to one end of the arms and on which we mount the propellers. And this cumulatively is known as a rotor. In this, the lift is produced by directing air downwards with the help of a rotor. That is a combination of motor and propeller. The naming of this is depends on the number of rotors, that is the number of propellers or number of motors that you have on an aircraft. So if you have two, it is known as a bicopter. If you have three, it is known as a tricopter. If you have four, it is known as a quadcopter, and so on. So the main classification of multirotors is mainly done on the number of arms of the multicopter. The third being VTOL. It stands for vertical takeoff and landing. It is a combination of fixed wings and multirotors. This is mainly used in areas where you have like space constraints, but you need to have the efficiency of a fixed wing. So in this case, you can see the multi-copter part of the UAV, and this multi-copter part of the UAV is used to raise the UAV aircraft. And then after it has reached a certain height, the main propulsion of the fixed wing kicks in, and it drives the aircraft forwards. And after getting a certain horizontal velocity or speed, the multi-rotor aspect of the UAV dials down or it cuts off. And then when coming into landing, the main fixed wing propulsion system will dial down, and the multicopter uh, part of the UAV kicks in. This is mainly used in situations where you need to have very high payload and you need vertical takeoff and landing capabilities. Lastly, being ornithopter. This is basically an aircraft that flies by flapping its wings. It is mimicking bird flight. This is one of the most recent technological advancements when it comes to UAV. It is still in the development stages. You can get like toys or hobby grade stuff of an ornithopter, but the wide implementation in the commercial field is very much less when compared to the other three. In this session, we'll be mainly concentrating on fixed wing and multi-rotor. So before we go on to what multi-rotor or multi-copter is made of, we need to understand the forces that are being acting on the aircraft. This is essential to know as to in which direction the aircraft moves and what the aircraft does in the space. When it comes to fixed wing, you have thrust that is provided by the propulsion system. It will be acting in the direction of the motion, and opposite to that you'll have drag. Opposite to thrust you'll have drag, and air flowing over the wing will produce lift perpendicular to it, that will be acting upwards, and the weight of the airplane will be acting downwards. So this is essential to consider when you have to take into consideration as to how much weight you have to carry and what are the drag aspects, how much fuel you want, how much battery. In case of UAV, it is how much battery power you need to have in order to complete a UAV mission. So it is very much essential to know what are the characteristics of the aircraft when it comes to lift and the weight. It is contradicting because if you want to have a good lift, you have to have some lightweight aircraft, and the thrust depends upon the propulsion system, the motors that is selected. When it comes to multi-rotor, the thrust itself is provided by the multi-rotors and it will be acting upwards. So the thrust itself will be the lift, and the drag will be always opposite to lift, always opposite to thrust, and the weight will always be acting towards the center of the earth or downwards to the aircraft. This is when you consider the lift off position or the landing position. But if you want to move, when you just look on the right side, right figure. So, but if you want to move the aircraft in certain direction, when you tilt the aircraft, the thrust vectoring, that is, you resolute the thrust in two aspects. Some part of the thrust will provide lift, that is to maintain the aircraft on in the air, and some part of the thrust provides forward motion. So you'll be resolving the forces in two directions. This is very much essential as to you have to consider which rotors you have to give more power and which rotors you have to give less power, and accordingly you will determine the direction of motion of the UAV, in this case multi-rotor. Here, this is very much essential when you consider the movement of an aircraft. We usually denote the movement of an aircraft in three words, that is roll, pitch, and yaw. Considering pitch in the first case, you can see a red line, that is axis that is perpendicular to the direction of travel. That motion is known as pitch, and in the direction of travel, that motion is known as roll, and perpendicular to both in the acting of upwards direction, turning about that axis is known as yaw. What are the applications of UAV? So mainly they are widely used in mapping and photography. Mapping in as civil purposes, and photography as in uh, it's kind of a hobby or a professional field. Disaster management. This is mainly used in flood scenarios or landslides, whereas one needs to assess how much land is being lost or what are the damages are being caused to the environment. Search and rescue. This is widely used in flood or stranded people, as to know where those people are stranded. Rather than sending a helicopter, it is much more economical and safer to send a UAV. In agricultural purposes, like spraying pesticides or crop health monitoring, crop yield estimation. In defense and surveillance, as in army, air force, so they'll send large drones that have very powerful cameras. That defense and surveillance, and entertainment and a hobby. This is mainly entertainment, as in some people might have interest to build a drone, and then hobby in the sense you might have heard of FPV drones or racing drones. So these are some of the applications of UAV. Some of the major applications. There are many other applications, but these are the ones that stand out. So coming to the basic components of a UAV, these are the bare bone minimum components that you might need to fly a fixed wing or a multi-rotor. We'll be only concentrating on these two on this session. Frame is the structural backbone or something that supports all the other components. So it provides the framework and support to mount all other components. Usually, we see that carbon fiber or dense foam are commonly used. It is because carbon fiber is very stiff, but it has a little bit of flexibility and the strength that it is unparalleled for the weight that it weighs. It is very much light and it has very high strength and a little bit of flexibility, because too much rigidity, in case of landing or the forces that are being acting on the aircraft, if it's too rigid, it might snap in the air, or while landing, the momentum of the aircraft when hitting the ground, the frame must be able to give weight. That is, it should be able to absorb some of the impact force. And dense foam is usually used in fixed wings. It is mainly because the overall weight, because in fixed wing the forces acting are not that great, because when you come to land you can have a landing gear or you can belly land, so the overall forces is comparatively less when it comes to multi rotors. um, uh, Dense foam is widely used because foam, as the characteristics of the foam, will have little bit of air pockets, and those air pockets help in reducing the weight. So dense foam is commonly used in frames. Flight controller is the brains of the aircraft. The main function of the flight controller is to convert the input from the receiver, that is the signals that have been sent by the pilot, to signals to drive the aircraft. If you consider a multi-rotor, if the pilot sends a signal that is pitch forward or go up, the flight controller converts that signal into individual signals for the motors. If you tell quadcopter to go front, it should dial down the RPM or the speed of the front two motors, and it has to increase the speed of the back two motors. So the main function of the FC is to make that happen. And the secondary function is for autonomous flight. That is the all the other components that are being attached to the flight controller. It will coordinate with all those components, and by the map or the flight path that is provided by the pilot, it follows that map with the help of these components, and it is responsible for coordinating all the functions of the aircraft. The pilot sends the signal to the aircraft, as in if it has to click a picture or it has to perform a certain maneuver. So the flight controller is responsible for coordinating all those actions. This Pixar Cube, the flight controller on the left, is mainly used for professional grade applications, like big multi rotors, like in case of pesticides or aerial mapping. The one in the center is mainly for hobby grade, that is for FPV racing drones, freestyle drones, all those things. These are comparatively small and are made to save on weight and space. And the third one is being autopilot or APM flight controller. This is usually suggested for entry level or beginner pilots who are interested to join into the hobby. This is fairly inexpensive and you'll get a touch into what aircraft handles. Global positioning system. This is very much essential when it comes to the autonomous aspect, because you need to know the position of the aircraft relative to a point, or very well relative to the map. So usually some of the flight controllers will have a barometer, and barometer it is used to determine the height of the aircraft from the ground. But in some cases, if you it is also kept in it is kept in the GPS, and the magnetometer also is kept in the GPS. This is mainly because GPS can be placed fairly far away from the aircraft or at a certain distance, so it does not cause an interference, like electromagnetic interference or sound, or the changes in air pressure due to air moving over the aircraft. So this is mainly used. The GPS is mainly used to track the location and send the information to the flight controller. And some of the flight controller will have barometer and magnetometer to determine the height in terms of barometer. A magnetometer acts as a compass. It is used to measure the heading, that is north, south, east, west, of the aircraft relating to the north, south, east, west of Earth. Motor is the one that provides thrust or lift. So it is an electric motor used to spin a propeller. It spins and in turn generate lifts. Brushless DC motor is widely used in UAVs. It is mainly because UAVs, there will be a lot of wear and tear on the motors if you use brushed motors. So brushless motors are preferred, and these are DC brushless motors, as in the naming of the DC brushless motors are such that the power that is derived is in terms of DC. That is the power stored in the batteries DC, and then it is converted and fed into certain varying signals to the motor. So motors are mainly classified based on their stator size and kV. Stator size is nothing but the diameter and the height of the motor and the windings, the stator and the windings. So this is very much essential to know what is the power that is required by the aircraft, or the power output of the motor. And kV is, in brief, the number of revolutions that a motor will output for a single volt that is being applied to the motor. This is necessary to determine the RPM of the motor, and also what prop size you should fix onto the motor. So mainly the classification is based on stator size and kV. You also need to take in care like what is the voltage range of operation of the motors, because some motors will have thicker windings and some motors will have thinner windings. So there will be a voltage range that will be specified for a motor. Usually it is 4s to 6s, that is the cell voltage. And if you go above or below, there are chances of you burning up these windings. So it is very much imperative that when you are choosing all the components of the flight of the aircraft, you need to consider what is the voltage range, what is the operation voltage range of each of the components. Electronic speed controller. This is in conjugation with the motor, because the motor needs a three-phase signal, that is varying three-phase signal to rotate. But the power that is being provided by the battery will be DC power, and it will be a steady signal. So ESC is used to regulate the speed and RPM of the motor, and this ESC converts the signal from the FC, that is the signal that is provided to each of the motor, whether to speed up or slow down, to varying frequency of the three-phase signal. We'll come into this later on. ESC are mainly classified based on the current draw on the working voltage range. Current draw as in how much current that is being drawn by the motor, and it depends upon what is your weight of the aircraft, what is the propeller that you have chosen, and also varying other conditions like the altitude and also the overall environment, and also the conditions also play a vital role on what is the current draw of the aircraft. So it is very much like a safe way to choose an ESC is that you need to have a little bit of headroom for each of the ESCs, because if a maximum amp draw of a motor is around 40 to 50 amps, so you have to, it's better to choose a ESC that is being regulated for around 60 amps, because there will be like peak a burst of current in case of sudden throttle up or sudden throttle down. So there will be bursts of currents, and these bursts of current should not exceed the current threshold of the ESC. And the voltage working range is applicable to all the components. That is, you have to have a certain number of voltage range that you have to supply for each of the components. Servo. This is mainly used in fixed wings for controlling the control surfaces. So servo is basically an electromechanical device that is used to obtain linear motion, that is to and fro motion, and rotatory motion. Linear motion is obtained by attaching a link in to the arm of the servo, and that when it rotates, it gives linear motion. If you want to give rotatory motion, you can it depends upon how you if you connect directly the control surface to the arm, you will get rotatory motion. If you control it by a link, you will get linear motion. It is used in fixed wing for controlling the control surfaces. Control surfaces are the one that enables a pilot to rotate, to roll, pitch, or yaw the aircraft. In This is in fixed wings. In multi rotors, this is done by varied like variation of the RPM of each of the motors. And in both the cases it is used for dropping and actuation mechanisms. Dropping as in if you have a payload to drop, so you can use servos like not the 9 gram servers are pretty light, but you can get 27 grams, 36 grams, 45-gram servers. So those are heavy duty servers. And also you can actuation mechanisms, as in if you want to activate like a electronic circuit or something, or a mechanical mechanism, you can also use servos. The propeller is the part that goes onto the motor. So it converts the rotatory motion of the motor into a airstream which pushes the aircraft downwards. Propeller is attached to the motor at its hub. The circular part of like the one that attaches to the motor, it is called a hub, and blades are attached to this hub. Propeller is mainly classified on the number of blades. You can see there are 2 blade, 3 blade, 4 blade, and 5 blade props, and the diameter of the prop, and also the pitch. So the main thing that you consider here is, if when you go to 2 blade or 3 blade prop, it is much more efficient than a 4 blade or a 5 blade prop, because as you increase the number of blades, there will be added drag into the there will be added drag to the aircraft. But if you go with the more bladed prop, then you'll get a little bit more performance or thrust. And also the diameter of the prop, that is, if you consider an end point of a prop and if you rotate the prop, it creates a circle, and that it signifies the diameter of the prop. And pitch of the prop is, if you rotate the prop by one revolution, the distance by which it travels for that one revolution is known as the pitch of the prop. Battery is the powerhouse of the aircraft. So the batteries that we commonly used are lithium polymer batteries, and these store DC charge. Batteries store DC charge, and batteries differ in the number of cells, thereby the voltage range at which drone operates. So when you come to lipo batteries, each cell can be charged to a maximum of 4.2 volts, and this 4.2 volts will be outputted by each of the battery. And the safe working range for a lithium polymer cell is 4.2 to a lower voltage of around 3 volts. 3 volts is the absolute minimum. You can go, 3.3 is considered as safe, but there's some batteries you can discharge up to 3 volts. If you go anything lower than 3 volts, then the battery is considered as dead. You cannot recharge. It's very hard to recharge it again, and even if you recharge, you might not get the optimum performance. And when you consider batteries that are used in UAVs, they usually stack up these cells. That is, if you have 2 cells, you'll be multiplying the voltage by 2. So correspondingly, you'll have 3 cell, 4 cell, 5 cell, and 6 cell. So when you go to a greater cell, you'll get better watt hours. That is the capacity of energy that you can store in the battery. And each of the voltage that is being provided by the battery also changes by the number of cells you add. For example, if you add 6 cells, that is 4.2 into 6, you'll get a maximum range of 25.2 volts. So you have to consider, usually we, as a thumb of rule, we consider a battery first, then we, depending on the battery and all the other components, we choose what is appropriate for the UAV. And it should be noted that this is a dangerous aspect of a UAV, that is handling the battery. If you short circuit or if you plug it incorrectly, there's high chances that the battery might explode. There's also another type of batteries that are commonly used, that are lithium ion batteries. And those batteries are commonly used because they are much more efficient, as in you can drain the voltage of each cell much lower. You can drain up to 2.6 volts, and the battery will still perform fine. So that is mainly used for long range missions. But the drawback of that is it is very much current draw dependent. That is, you can't draw much current from lithium ion cells. Usually it maxes out around 30 amps, 20 amps. That is the common range of lithium ion cells. But in case of lithium polymer batteries, you can discharge up to 100 amps, 200 amps easily. And there's also, like, there are certain aspects coming to a battery. You'll also have the discharge rate that we'll look into later, later on, the overall brief characteristics of the battery. Radio transmitter and receiver, this is what that is being held by the pilot, and the pilot gives the inputs or the inputs or on which, on how UAV must perform. So he inputs the signals through the sticks. Usually, you'll have two sticks, and they'll have 4 degrees of motion. That is up, down, left, right on both the sides. So usually we use a motor transmitter in India. So in that you'll have a thrust, that is to go up or down on the left side, and yaw. You have to push it to the left or push it to the right. That is yaw. And on the right stick, if you on the up down direction it is pitch, and on the left or the right direction it is roll. So the transmitter converts this input from the pilot to signals that are to radio signals. And this radio signal, commonly used radio signal, is a 2.4 gigahertz radio link. We also use 8.868 and 915 megahertz links, but it is mainly used for long range systems, because as the frequency decreases, the penetration power and the carrying capacity of the radio wave increases. So the other aspect of the radio link is receiver. So it gets this radio signal, and it converts into a protocol. A protocol is basically like a signal that FC might understand. So usually we have PWM, pulse width modulation, PPM, S-bus, CRSF, and others. So the most commonly used is S-bus, because it is a serial bus protocol. You can carry all the signals over single wire. And you have to take into consideration, because some FCs will only take PWM signals or PPM signals, S-bus signals. So while determining what radio you need to take, you should also look into that the output from the receiver is supported by the FC. So coming to the wiring diagram, this is in terms of a multi-rotor, more specifically a quadcopter. So you can see this is a flight controller. So all of this goes onto a frame. So it is essential to assemble a frame first. You can also assemble it like a spread out view, but it is when you assemble onto a airframe, you have to consider that there will be certain arrows on the flight controller. So these arrows, for example here, these arrows should point in the direction of the front of the aircraft. That is the aircraft portion that denotes the front. So you need to point the flight controller in that direction. This is because the flight controller will take that front as a reference and will output the signals for each of the ESCs. So and this flight controllers, usually most of them are soft mounted. Soft mounted in the sense you will have rubber gummies or dampers that remove the vibration from all the aircraft components, because motor while rotating it might cause unintended vibrations, and if these vibrations pass into the flight controller, they will disrupt the gyroscope, accelerometer, and give wrong readings. So usually all flight controllers are soft mounted. You can also use tape, like a double-sided tape also acts as a damper. But some high-end flight controllers will have a like inbuilt damping system. And after connecting the flight controller, we connect the radio signal, that is the RC in, and then depending upon the number of motors that is being used, here it is four. We mount the four motors on the four arms, and it should be noted that for each of the flight controllers there will be motor mapping. That is, the flight controller will say which is motor 1, which is motor 2, which is motor 3, which is motor 4. You have to connect those motors accordingly, because if you mismatch those connections, the flight controller will think you have matched it correctly. But if you have matched it wrong, there's high chances that it will flip out or it will not take off at all. And if you see in this case, you can in this case they are used a 4-in-1 ESC, but you can also use a like individual ESCs. And you can see that for the four motors, two motors are rotating in one direction and two motors are rotating in the other direction. When you have a spinning object, there's something known as a turning moment or a rotating moment. So if all the motors were to turn in the same direction, then the motor would rotate as soon as it takes off. So it will rotate about its center of axis or the CG, and this is not required. So in order to counteract this, we keep two motors in one direction and we reverse the direction of the other two motors. So this counteracts the turning moment. And we should also note that as the rotation is reversed, the propeller will also have two variants. That is, it will be clockwise propeller or a counterclockwise propeller. And this is very much essential because a counterclockwise propeller will not generate the same thrust if it's rotated clockwise, and there will be a lot of vibrations if you put the wrong propellers on the motors. Then usually a flight controller is powered by a 5-volt source. So we'll have a battery elimination circuit or a voltage converter that is connected to the lipo battery, and this in turn provides power to the flight controller. And this the native power, that is the voltage that is being supplied to the by the lipo battery, this is in turn fed into the ESC. The ESC, in terms of the PWM output, the signal output from the flight controller, regulates the signals to each of the motors, and they rotate accordingly. So it should be noted that the lipo battery, the raw power, that is the native voltage, should be fed into the ESC directly, and then it's like it's a precautionary measure that uses a battery elimination circuit. Usually, it will be provided to the flight controller, but there are flight controllers that take in native voltage also. Usually, when you have a lipo battery direct input, you should have some kind of filtration because there will be certain surges, and these surges might draw like affect the or damage the flight controller or any of the components. So it is advisable to check whether it has filtration. If there is no filtration, then it is necessary to have a battery elimination circuit. The GPS is also connected to the flight controller. The GPS will also have a like arrow mark pointing which is the front direction. That yeah, that in turn gets the basic components done. So there are other components like the telemetry system. These are mainly like an advanced, so you might not need it when you're starting off, but that enables like very high end professional work. That is, you'll get real time data from the drone and all this stuff. And a safety switch is necessary because you might not there will be a case if you by mistakenly bump the transmitter, and if you might throttle it up, and then the UAV might lose the control. So in order to do that, after you plug into the AC, after you plug in the battery and the quadcopter initializes, you push the safety switch that tells the flight controller to ready itself and then be ready for takeoff. We'll be getting a brief idea as to how we set up the multi. This is in terms of usually I'll explain in terms of a multi-rotor. So first we assemble a frame and we wire up the components. And usually wiring like varies from flight controller to flight controller. And each of the flight controller will have like a wiring diagram. So you need to follow that. And next, before you even plug into the battery, you need to check for electrical shorts and reverse polarity, because if you have a short like if a positive and negative are touching each other, or positive is touching to the frame, usually carbon fiber is electrically conductive, so if it touches the frame, then it will short the all the connections. And usually the consequences of short is, if a short is very much closer to the battery, then the battery will explode. If it is very much if it's after certain components, then excuse me. Okay. If it is after the flight, like any other components, then it will fry those components. And if in case of reverse polarity, if you connect it like positive, negative in the other direction, it will fry the components. And usually this you can check the electrical shorts by using a multimeter and connecting to the two power leads. If there's continuity, then that indicates it's a short. If there's no continuity, then you're safe to go. And reverse polarity, like there are some devices that can check reverse polarity, but it is like a thumb rule to color code your cables, that is red for positive and black for negative, and then you proceed with the wiring of the components. Then you have flashing the firmware to the FC. Firmware is something that it's like an operating system to the FC. So initially, there will be firmware on the FC, but it is like a thumb rule to update the firmware of the FC. Then we have to calibrate the FC. Calibrating as in you have to calibrate the gyroscope and accelerometer to know, like what is the stable position, what is the laying flat position, top, right, front, back position, all those things. And Then you have to calibrate the battery voltage. This is mainly done to give warning to the pilot as to what is the battery level of like the battery percentage available of the aircraft. Then you have to calibrate the GPS, accelerometers, and checking the radio link. Like if you pitch up on the radio, whether it the same input reflects on the FC, and then you have to set up the control channels, as in what if you, there will be a lot of many switches on the transmitters. So each moving each of the switches, you can add like if you move one switch, then drop a payload may drop. Then you can set different modes, like if you want sport mode, or if you want level mode, or acrobatic mode. So setting up those channels is the next, because unless and until you set up channels, the quadcopter will not get to know what you want the UAV to do. Then after checking everything, checking the direction of the rotation of motors. For this, you have to connect the connect the battery to the AC, and then you have to check whether the direction of rotation that is being given in the wiring diagram is the same as the direction of rotation of the motors. In case the direction of rotation is opposite, usually in ESCs you can just interchange the two of the wires, and the rotation of the motors will change. If you have soldered the connection, some of the ESCs will also allow you to change the direction of rotation in the software itself. And then you have to, on the depending on the rotation of the motors, you have to also choose the right direction of props. As in, if the motor rotates in clockwise direction, you will put a clockwise prop on. Anti-clockwise direction, it will put a anti-clockwise prop on. And coming to UAVs, there's always a thing called as arming. That is, when after you connect the battery and after all the quadcopter initializes, you have the pilot must manually arm the quad. That is by moving a switch. Arming the quad tells the UAV to be ready for takeoff. And before taking off, you have to check all the controls. That is whether all the control surfaces are moving in fixed wing. And in terms of UAV, when you arm the UAV in a multi-rotor, the all the rotors will start rotating at like 5% or 2% total maximum speed. By that, moving the pitch and your all those channels, you'll get to know whether the increase or decreasing speed in each of the motors is accordingly what you desire. And then after all the controls are checked, you are ready for takeoff. And finally, this is like a very important aspect when it comes to flying drones. So we have a regulatory body in India, that is DGCA. So it has set up certain guidelines that one individual must follow while flying a UAV. So mainly the classification is based on weight. As you can see, nano is less than 250 grams, micro is 250 to 250 grams to 2 kg, small is 2 kg to 25 kg, medium is 25 to 150 kg, large is more than 150 kg. So the rules are applicable on each of the type or category of UAVs. It varies. In case of nano, there's not much restrictions, because essentially you consider it as a toy. There is not much danger when it comes for flying nano. The some of the restrictions is that nano should always be flown below 50 feet, and micro should always be flown below 200 feet. Then there's like a UAV registration portal, that is digital sky. So it is imperative for all pilots or manufacturers, whoever designs UAV, to register their UAV in this digital sky platform. This was brought to you by the government of India last year. And in this, usually the government signify as a UAV in terms of RPS, that is remotely piloted aircraft system, MRPS, that is model remotely piloted aircraft system, and unmanned aerial system. So when it comes to registration of your drone into a portal, first, as you have like when you come to registration into any portal, you will have an individual account. So that is the you have to create your own account, and this is based on your Aadhaar. And registering yourself into this platform, you'll get a ownership acknowledgement number, OAN. And then after you yourself have registered into this platform, you have to register your drone. And registering your drone, you'll get your drone acknowledgement number for that specific drone. And then your drone will be given a number, that is unique identification number. This unique identification number is a way by the by how government of India recognizes your drone, so that it can track back if in case whatever happens, or if you lose your drone, or if they want to keep ties on your drone. And the policy that government of India they have put forth is no permission, no takeoff. That is, in case the system that they are proposing is that you'll be connected to the internet. The pilot will have an app, and that app will be connected to the UAV. So when the pilot wants to fly the UAV, so first they have to take permission from the aircraft control, and then only if they give permission, then if the aircraft control gives permission for takeoff, then only the aircraft should fly, or else the aircraft shouldn't fly. So this is the policy that the government puts forth. But there are like a handful of drones that are following this policy. Not even the well-known drone maker DGCA has implemented such kind of thing. This is in its infancy and is soon to take off in the near future. There are hardly like 10-15 drones in all of India that are compliant to this policy. And when it comes to nano and micro category, you need not need any permit to operate. Permit as in license. So any aircraft other than less than 2 kg, you need not have a license. And these licenses are usually done like there's one like a facility known as Bombay Flying Club in Mumbai. They give you training, and then they issue like a license for usually small category, that is until 25 kg. Anything more than that, you have to undergo specialization courses. And no drones cannot be flown more than 400 feet vertically unless until you have special permission and clearance from the aircraft control. Because uh, this is the point from which the airspace starts. 400 feet and above is the area in which aircraft typically fly when takeoff and landing. And so unless and until you have special permission, it is never advisable to fly your drone more than 400 feet. And drones cannot be flown in areas specified as no-fly zones. No-fly zones include line of action, or 5 kilometer radius around an airport, or parliament buildings, administrative buildings. So you are not supposed to fly there unless until you have special permission. Unless until you have clearance from an authority, you are not supposed to fly there. And it is always required to fly your drone in visual line of sight during daytime. This is imperative for drones which do not have a camera or a real-time video logging feature to the pilot. Usually during nighttime, some of the drones might have infrared cameras, so that rule ain't applicable because you'll not be able to see the aircraft. But during nighttime, it is imperative that you'll have lights on the aircraft. It is compulsory to have lights on the aircraft so as to identify where the aircraft is heading. So these are the some of the important. These are not all the info rules that are being set on Digital Sky. These are some of the most basic and like the rules that you have to follow. Like these are very strictly monitored. So if you in case if you break or violate any of this very hard and fast rules, then you'll be facing dire consequences fines up to 50,000 or imprisonment up to 2 to 3 years. So it is very much imperative to know what you're doing. The overall the law is not very stringent to nano and micro category, but if you want to fly your drones in public places, you need to have permission from like a regulatory body like police station. You have to inform them first and then fly in public places. And while flying in public places, ensure that you have return to home feature. That is, in case if you lose contact with your drone, the drone must be able to fly itself back to where it landed from, or back to until it regains the radio signal. So these are some of the precautions and safety and regulatory aspects when it comes to flying UAVs in India. Yeah. So that concludes today's session. It's basically an introduction to what a UAV is, and now we'll be having a Q&A session. That is, I'll try to answer your questions. So if you have any doubts or if you have any clarifications, please feel free to ask.
Yeah, actually, I had a drone,
Yeah.
UAV drone,
Yeah.
and I had a controller of it. But while I adjusted it and started uh, running it, it went out of control. Like the controls weren't working.
Okay.
So,
Which
what
flight
would be
controller?
the reason to it?
Yeah, it depends upon the flight controller. Which flight controller do you use?
I had uh, not the racer drone, the other one.
The APM.
Yes,
Okay, usually you'll have something known as. Did you set failsafe? Failsafe as in if you don't get any signal or if there's any mismatch of signals, the drone will execute that failsafe. So usually, what failsafe you have to have is cut off. So as soon as the radio signal, there's no radio signal, it is imperative that the drone should fall down to the ground. So what did you set over there?
actually, I it matched frequency for its frequency first, and then
Okay.
I uh, I started the drone. I moved the drone upwards, but after pressing the up button, it when I stopped pressing it, it was still moving upwards.
Like when you stop pressing in the sense, could you be more clear?
In the sense, I pressed the button upwards.
Okay, okay. Which like are you using radio? Which radio control or something?
Pardon me.
Which radio controller are you using?
Um, Not the racer drone one, the other one.
No, no, no. The controller, the radio, not the flight controller.
Uh, I
Hello,
don't remember.
Jatin. I would like to
Yeah,
answer this.
yeah,
Yeah,
yeah.
this is Anand. May I know your name, whoever is asking the doubt.
Amar,
It was, yeah.
What is your name?
Amar.
Amar. Hey, Amar. So I'm Anand. I work for Tata Defense and Aerospace as a drone pilot. Okay.
Yes, so
So there are something, as I heard your questions, the two things. One is your throttle is not calibrated. Okay, and another thing is your GPS lock should be there. There should be at least 9 satellites before you take off. If you're not monitoring that, or if your compass calibration goes wrong, if you're flying in any no metallic object is surrounded and you're flying in that area, there will be compass calibration error, and for which your drone will start behaving weird. This happens not only with our own drone, but also with the costly drones, which is costing you 25 lakhs, 30 lakhs. Even for those drones, if you're flying in a metallic surrounded place, okay, then your compass calibration will be spoiled. It will start playing weirdly. Okay, that is why costlier drones will be having dual redundancy. It will be having dual compass. It will be having dual GPS locks. So those are the special features that are available for bigger drones.
Hello.
okay. So this is applicable for smaller drones as well.
Yes, yes, this is applicable for some smaller drones. You shouldn't fly when there is high tension wire. You shouldn't go near the high tension wire, and you shouldn't fly wherever there is no concrete, because concrete is made up of, once again, no, or underneath it, it will have a lot of iron built up there. So you shouldn't be flying over there in that area. Also, you should be very careful. If you lift your aircraft from the ground little bit, like 1 or 2 meter above, uh, yeah, 1 or 2 meter above the ground, you'll be able to see that compass gets your GPS will be locked, or else your compass will be showing constant error. So before taking off a drone, you should do a multiple, we call it as ground checks. Okay, so without connecting your, without putting your propeller, you should have to do a multiple check whether the throttle you are not able to control, whether when you give right in your transmitter, is the drone going right? When you give left, is the drone going left? When you raise the throttle, is it responding? When you drop the throttle, is it responding? These are some checks that you need to, safety checks that you need to do before taking off a drone.
Hello, I have a doubt.
Okay.
Yeah,
Yeah.
Actually, I have made a drone, but everything is perfect, but it's not moving. It's moving one side.
Joshua.
Hello,
Yeah,
Vinay.
Josh,
Hello.
Vinay.
Yeah.
Yeah, Joshwin, you can take over.
Yeah. Thank you. Yeah. Could you tell the issue again, Vinay?
Actually, I have made a drone.
Yeah.
Everything is perfect, but it's moving one side. All motors are
Uh,
good.
did you check the propeller direction?
Yeah, yeah.
Okay.
Hello. Hello.
One side in the sense when you arm it and when you try to take off.
Yeah, it's not going up, but it is standing straightly. It is not going up, but it is standing like straightly.
Okay. And it goes sideways, right?
Yeah, yeah, yeah.
Uh,
Okay. Then usually you double check the propellers
Yeah, everything
or
is.
okay, okay. Usually that happens when you have uh, when you
yeah,
there's issue with the propeller direction.
for a better understanding, you can share a video of your drone in
Yeah.
our community channel.
Sure, sure. Where is the channel?
The link will be shared to
Telegram.
you in shortly in the same page.
Okay.
Okay, in the chats. Okay, so it is already there, I guess. Yes, it is already there. Okay, so you can put your video there, and then we'll be able to suggest you. Joshua will be able to answer you
Yeah.
more appropriately, because
Sure.
we might not know what exactly is happening with the drone.
In Telegram.
Yeah, in Telegram, yes.
Yeah. Yeah. In
Sure,
Telegram.
sure.
You can share your video, and we'll be able to suggest you things. So your drone is
Okay.
not moving right or left, or it is moving only in right. What exactly is happening?
Actually, every motors are rotating, but it is moving one side.
One side meaning? I didn't understand it. Is it
I'll
moving
share a
only in
video.
top
I'll
or
share a
left?
video.
Kushara Bajpai, please speak up.
Was asking a question. I was asking that if
Yeah.
we basically when we talk about quadcopters and multi-rotors, all those,
Yeah.
they we know for a fact that they are more agile compared to fixed wing aircrafts, right?
Yeah.
So, but
Yes, sir.
why still, as we see in the current scenario in the defense forces, why are fixed wing UAVs given more preference, as we see in the Indian Air Force as well, and the US military is using more
Sir,
fixed
sir,
wing
can you
compared
repeat?
to
Sir, can you repeat?
Yeah.
yeah. So that's why.
So yeah. So your question is why the aircraft the defense force chooses to choose fixed wing over multi rotors, right?
Exactly. Basically, what are the main
Yeah.
advantages?
Okay, the main advantage being its efficiency because when you consider fixed wing, the lift is provided by the wing, and you need not have certain like the only force that you need is vectoring the air, and then you'll get lift. So that is very much you'll get a lot of sorry. Uh, So could you yeah sure. Yeah, so you'll get a lot of efficiency when you consider fixed wings.
So efficiency, as in just the power would be needed for powering the engines,
Yeah,
and
the power will be the power needed to powering the engines and to obtain sustained flight is very much less. So you need
hmm,
not carry heavy weight. It will be like you can go up to more range. It's like that. Okay.
yeah. Thank you.
Yeah. Okay.
Yeah, adding to that, uh, yeah, the energy actually Joshua told it right. So the energy consuming,
Good,
the
good morning, sir.
the consumption of the energy is more. A four motor rotating in a drone and a single motor rotating in a drone, it makes a difference, and that is why we use a lot of fixed wings. And at the same time, fixed wings, there's a major problem in the fixed wing. We are not able to land it. Indian Air Force, Indian Army, they use it in a tactical environment, and you can't find a 200-meter straight, clear of line of sight land. So that is why now fixed wing is also being replaced by VTOL, vertical takeoff and landing. So that is more trendier in defense now. So all the research that has been going around is on VTOL, because it needs a limited area for takeoff and limited area for landing. So, and then when it comes to fixed wing, it can take much load, and then chances of failure is very less. Even though if the one motor fails, it can glide and then come back and land. Okay, with respect to multi-copter, it is very dangerous. If one motor fails, then it will be very extremely difficult and nearly impossible to control a multi-copter. Does that answer your question?
It does, and it in fact brings one more question into my mind.
Yes.
And, if vertical takeoff and landing systems
Yeah.
are considered, but as we have seen in cases of aircrafts, not UAVs, I'm not sure about UAVs, but in case of aircrafts, we have seen that when it's vertical takeoff and landing, along with the normal traditional aircraft flight, it is often found that the aircraft is usually a little unstable in performance as well. It is a little lower, which was seen in the case of the F-35s, and similarly,
And
the
even
Hack
Osprey.
was also taken back from the Navy because of its instability and reduction in performance compared to other traditional aircrafts.
Yeah. So we are talking about drones which are weighing hundreds of kgs. Okay, sorry, planes which is weighing hundreds of kgs. With respect to drone at Tata Defense itself, I lead a project. So for the CRPF. Okay, so for the CRPF and the NSG commandos. So for the CRPF and the NSG commandos. So it is an 18 kg bird, and we have been successfully demonstrating them for the past six months. VTOL, same conventional cord on which is uh, uh, which is on top of a fixed. That's it. Only when you take off, and then no, when you achieve. So it actually works like this. When you take off, when it climbs for 15 meters, and then a forward motor will trigger. So when the quad motors also will assist your forward motor for achieving 18 meter per seconds of speed. When the plane reaches 18 meter per seconds, the four motors, quad motors, will shut down, and the forward motor will take over the entire flying scenario. When it comes to landing, also it behaves the same. When it reaches below 30 meters altitude, and the speed reduces less than 18 meter per second, the quad motor triggers, the forward motor stops. So this is not that complex with respect to drones, but definitely, yes, as you told, this is very complex with respect to jets.
So, talking about that,
Yeah.
when we are changing from vertical flight to the conventional method, so
Yeah.
in that between, when we switch off these and power the forward engine,
Hmm.
does that actually have a little gap in which the nose might pitch down or something like that?
Exactly. You are right on the page. It happens. There will be a drop in the altitude.
Exactly. So
Yeah.
instead of doing that, can we have a system which basically, projects the aircraft at about 45 degrees so that it gives that initial push to it, and later it can be continued, and while recovering,
Can you
we
can
can.
can you come
Yeah,
again?
I'm saying instead of doing that, as it has some limit of drawbacks,
Hmm.
and the major advantage why VTOL is being used is to reduce area taken on ground for
Yeah.
takeoff and landing.
Yeah.
Instead of doing that, we can have a system which can project at a very high speed an aircraft at about 45 degrees or whatever, so that it has that initial push, and then it can continue, and while coming back it can be recovered into a net or something, as I was seeing for some drone it was being
Yeah.
used.
This has been this is also under implementation. You can see video of a company called a Zipline. Okay, so Zipline are a medical delivery company in Africa, and they are right now in contract with Maharashtra also, Indian government Maharashtra. So if you see their videos, they are using the same configuration. This is a Caterpillar launch, and then it will launch. By landing, it is a string landing. The landing is so precise. There's a small hook in the aircraft which comes and gets stuck to the string. Okay, you can see the video of zip line.
True, true. Thank you. Well
So
said.
yeah, there are a lot of multiple. This is completely R&D. There is no prominent, like aircraft wise, you can't say drone is finalized and things like that. So there is a lot of R&D that is going on nowadays. If you see China, they are into swarm. So they have foldable wings and caterpillar launch. So multiple research is going on. Keep thinking new. You also come up with new ideas. The market is still wide open. You can always compete in a lot of drone competitions that are being organized by the Indian government, because Indian Army, Indian Air Force, and Indian Navy are in badly need of drones which are capable of giving you better surveillance, and also giving you better strike at the enemy areas. Yeah.
Thank you, welcome, sir.
Hmm. Amar, you have raised your hand. You have a question?
Yes, actually, I was flying my drone in my hall.
Okay.
So, which place is preferable to
Eh,
fly a drone?
Better be outside because it's quite dangerous when you have spinning propellers. So better fly outside, and better fly when there's no much wind, when the wind is calm.
Okay, so it can be a garden.
Better like ensure that if it's a garden, then ensure that it is not in the morning, because in the morning you'll have dew, water. So if that gets into your electronics, then it might ruin your electronics. So try to get a place that has if you're gonna fly in the ground, then ensure that there's no dew, like in the evenings or something, and there's no wind. And if you're afraid that a drone might crash into pavement or something, then depends like what area you're comfortable with. Because as a first guy, you'll always be scared that you'll take off and something might happen and it might crash. And if it's a very tough payment, then there's chances you might break your drone. So what I did, I usually flew it in fields or something during evening times. So there's no dew during evening times, and you'll have a vast space. So where do you live?
I live at Tardev.
Like, do you have open space or something available, like
Yeah, there's
ground?
August Kanti Maidan out here.
Okay, ensure that there's no public nearby, and open space is preferable.
Okay.
Yeah. Anyone else? Questions? Yeah, wait a minute.
Yes, sir, I'm Dushyant.
Yeah.
Sir, can you make the free courses for making drones?
Free courses as in like we will have like sessions like this every time. For that,
Just,
you have,
just
yeah,
let me take over this question.
yeah.
Okay, I was just typing this answer on Telegram also. So let me just answer it here itself for the Dushan. So basically, these webinars, whatever we are doing, especially on for software, it's quite understandable. We can do it online, but especially when it comes to hardware. So this is just to provide you an awareness about what are the technology and what how just to provide you a, beginning point, starting point of where from which you can carry on forward. And we'll be having so more of such videos wherein you can learn from it and actually try to implement. And these videos, whatever the webinar is there, it would be pointless if you are not going home and try researching about it and trying it on your own. Okay, so this is about the webinar, this webinar that we are doing. So, and when it comes to like giving courses on such things like drones or anything related to hardware, it's very difficult to give it online. Okay, we might have to, or maybe we might have to send you the components and all of that. And also when it comes to hardware, the components are very costly. So doing it for free, it's highly unlikely, because as you know, we have to invest a lot on the components as well. Does that
Okay.
answer?
Ah, yeah.
Yes. So what are you what are your plans exactly? What are you looking for from these courses or anything?
I'm looking for that to make drones from this online sessions.
So may I know what you're doing exactly right now?
But I'm not doing exactly now. So I wanna
No.
get more informations about the drones and make the drone from it.
So I may I know which college or
What
which
class are you studying in,
what are you
Dushyant?
studying?
Eighth standard.
You're in eighth standard. Oh, that's really good that you're interested in such kind of a field. So keep your curiosity on. Okay, try keep researching about it. But all in all, you have to actually work on the hands-on on it. Where are you from exactly?
Bangalore.
Bangalore. Oh, great.
So Bangalore, where are you flying?
Dushyant, I'll be just handing over my system to Anand. So he wants to talk to you a bit.
Hey, Darshan.
Dushyant.
Dushant.
Okay. Yes, sir.
Yeah, you have been. Do you know to fly drone?
Yes, sir. I have tried in my friend's drone.
Okay, okay. That's really great. Great, you being each standard and then being oriented towards drone. So yeah, I'll be in Bangalore right now. I think if you would have met like 2 months back, then I could have trained you personally. Uh, just because you are young and you are no lot of there are not a lot of people who are oriented towards R&D of drones and things, but 5 years down the line is the future of drone in India. Right now we are still researching, so keep that zeal, and then if any doubt is there, definitely contact us. Since you are very young, we'll help you for free. Our suggestion will be for free.
Okay, sir.
Okay.
Okay, sir.
Yeah.
Any queries? Just get back to us in the Telegram group.
Thank you guys for joining.